Hello everyone, and in this video we're going to be working on organic chemistry and naming compounds and various other questions. So we're going to start with drawing 8 pentyl isomers. So pentyl isomers are isomers of pentyl, and pentyl has the formula C5H11. So how do I know what is pentyl? Because you're supposed to know it. So I know that pentane is C5H12, and pentyl means that the C5H something has to be attached to the rest of the molecule. So that just means, because pentyl is a functional group, right? Or like a side chain. So so because of that, I know it has to be 11 because it needs another bond to attach to this R. So it can't be 12. So now that I know that, let's start drawing the isomers. So we're going to start with just the usual normal chain, pentyl, and basically you can add hydrogens here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and this is going to be the rest of the milk, right? Rest of the molecule. So this is our first isomer. So the second isomer is going to be 1, 2, 3, 4, 5 here, and it's attached to the rest of the molecule here. And it's also going to be 11 hydrogens. You can just check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? So going further, I'm not going to be drawing the hydrogens because although you're supposed to, but let's just speed up the process and not actually draw them because it's pretty straightforward how to draw it. So the next one is going to be just like this one, but the C is going to be attached here, right? So it's pretty obvious. So another thing we can do is attach a C, another C in the middle. So for example here, right? And again, another, the fifth, we can just attach it to the second carbon, right? And this is the rest of the molecule and the rest of the molecule. So attach it to the second carbon. Okay, so we have 5. What else can we do with it? Well, we can attach 2 carbons onto the same carbon, right? And again, if we wanted to check the hydrogens, it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? Okay, so number 7, we can again do this, but with a third or a first carbon. So let's do it with the first. And the last one, we can, do it with a third. So it's in the middle, just like that. So it's a pretty straightforward exercise. Again, you can check the hydrogens, say on this one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so in this exercise, they're asking, is the carbon primary, secondary, tertiary, or quaternary? So they're asking for the main carbon, so this carbon. And so asking is it primary or secondary just means to how many carbons is it attached, right? So a primary carbon is bonded to 1 other carbon, a secondary is bonded to 2, a tertiary is bonded to 3, etc. So let's draw this main carbon. This is this one. So it's a C, and it's attached to some group here, which is again a carbon. It's attached to a carbon that has something else attached to it, right? It's attached to a carbon here and it's attached to a carbon here. It's also attached to a hydrogen. How do I know it? It's because if you look here, okay, so what do I see? I see a carbon attached to a carbon, attached to this carbon, and these hydrogens, I could just draw them like this if I wanted to, right? Again, and this is the hydrogen it's attached to, but it's also attached to this carbon right here, and this hydrogen can go up, right? Okay, so basically how many carbons do I see? 1, 2, 3. So it's a tertiary carbon. So again, the question isn't there. They're asking, is the carbon primary, secondary, or tertiary, or quaternary? So we can just look here. Let's see. So carbon attached to one carbon, attached to this carbon. This can just go like this. Attached to this carbon and to this carbon. This is 1, 2, 3, 4 bonds to carbon. So this hydrogen cannot be here. It should be some sort of mistake because the carbon can only ever have 4 bonds. We cannot have a pentavalent carbon. But yeah, so basically here, if you look at this, this is carbon 1, 2, 3, 4. So this is a quaternary carbon. Okay, let's move on. Draw a structure that contains an isopropyl group. Okay, so what is an isopropyl group? A regular, okay, so first of all, isopropyl means propyl, but some sort of irregular propyl, not normal, right? Because normal propyl is just called propyl, or sometimes it's called N-propyl for normal propyl. So it's some sort of irregular propyl, and what it is, it's actually just a propyl that has the carbon chain or the rest molecule attached to the central carbon. It's attached to hydrogen. These also have hydrogens on them. But basically what makes it an irregular propyl is that it's attached to the rest of the molecule on its middle carbon. So draw a structure that contains this isopropyl. So we can just draw whatever we want. 1, 2, 3, 4, 5, 6 carbons. It doesn't matter. And then we can just attach a isopropyl group here. And we can fill in the hydrogens. We need to fill in the hydrogens. Sometimes we can make like double bonds. That's fine. If you really don't want to fill out the hydrogens, but it doesn't really matter. So each carbon has to have 4 bonds. So 1, 2, 3, 4. 1, 2, 1, 2, 3, 4. Good. 1, 2, 3. So it needs a hydrogen, and this one has 1, 2, 3, 4. Okay, so again, draw a structure that contains tert-butyl group and has 2 tertiary carbons. Okay, so there are 2 conditions. So it contains a tert-butyl group and it has 2 tertiary carbons. Tertiary carbons means carbons that are bonded to 3 other carbons. And the tert-butyl group is shown here. So why is it tert-butyl? Tert-butyl, it's not a regular butyl, it's an irregular butyl. It's not a normal butyl. Why is it not normal? It's because it looks like this. The rest of the molecule is here. it sort of looks like a T, so people call it tert butyl. The regular butyl is a chain like this with hydrogens, everywhere. Yeah, but they're giving us a structure of tert butyl, and they're asking us to draw another structure that contains this structure. So we can just draw whatever we want, right? Can make some triple bonds, whatever I want. And then I need two tertiary carbons. So tertiary carbons means carbons bonded to 3 other carbons. So let me undo one of my triple bonds and make a tertiary carbon. So a tertiary carbon is bonded to 3 other carbons. So here I have a tertiary carbon, right? 1 carbon bonded to this carbon, bonded to this carbon, bonded to this carbon. This is my tertiary carbon. Let me make another tertiary carbon. I can even make it right here. This carbon is also tertiary because it's bonded to 1 carbon. Oh, this one actually doesn't work. Never mind. This has to be a hydrogen. Now we have a tertiary carbon because it's bonded to 1 carbon, 2 carbon, 3 carbon. We have a tertiary carbon bonded to 3 other carbons. Okay, let's move on. Now we have to attach our tert butyl group. Let's attach it here. So it's a C for the C, and then 3 methyl groups right next to this C. And now you just have to fill in our hydrogens for whatever we didn't fill in. So this carbon is not saturated, it needs some hydrogens. So this carbon is fine, it has 4 bonds. No, actually it needs another hydrogen. So 1, 2, 3, 4. Now this carbon, 1, 2, 3, 4. This carbon, this one is fine. This one needs some hydrogens. Same for this one. So this carbon has 1, 2 bonds. So it needs 2 other hydrogens. And this carbon has all 4 bonds. And so do each of these carbons. They also have all 4 bonds. Okay, so now we need to name this compound. So first thing we need to do is to number our carbons. So we're going to be numbering them from this end because so if you look at this here, there's 1 carbon, 2nd carbon, 3rd carbon, and on the 3rd carbon we have some functional groups. But if we go from this side, we have 1 carbon, 2nd carbon, we have a functional group. So we're going to start naming them from the side that has more functional groups. Yes, so 1, 2, 3, 4, 5, 6. So straight away we know it's a hexane. Now on the carbon 2 we have a 2 methyl group. Methyl because it has only 1 carbon. On the carbon 4 we have a methyl. And we also have an ethyl. Ethyl, 2 carbons. 2 carbons is an ethyl. So all we have to do now is put them together. It's a 4-ethyl. Why does 4 go first? Because E goes first in the alphabet before M. 2, 4 dimethyl because there are 2 methyl groups. Hexane. Okay, so the next one. Which side do we want to start numbering carbons? This side, right? We want to start right here. 1, No, we want to start right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now it's a decane. Now functional groups. There's a 3-methyl. There's a 4-methyl. There's a 7-methyl. So now we just put them together. So 3, 4, 3, 4, 7, trimethyl decane. Draw the structure. Okay, so let's start with the backbone of the molecule. So decane, so 10 carbons. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 7, 6, 7, 8, 9, 10. And let's number them. Okay, so 2, 3, 3 tripropyl. So on carbon 2 and on carbon 3, we have some propyl groups. Propyl means C3H. So propane is C3H 8. So propyl is C3H7. H7. Again, there's one here. There's one here. Okay, so on carbon number 5, there's a methyl butyl. There's a 2-methyl butyl. Okay, so what does that mean? That means, at first, let's draw this here. So butyl 1, 2, 3, 4. It has a functional group, which is a methyl, right here. So a methyl, we actually can just draw it like this. You don't have to specify that it's a, CH3, but it's also okay to specify. Like, it's fine. And it will make your life easier and make you do less mistakes. Okay, so now what we want to do is put this functional group onto our 5th carbon. So we do this. 1, 2, 3, 4. Let's do it horizontally. 1, 2, 3, 4. This is our butyl, right? 1, 2, 3, 4. 1, 2, 3, 4. And a methyl group right here on its carbon number 2. Okay. Then on carbon number 6, there's a 2-methyl pentane. So again, pentane. So 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5. No, one too many. So if we were to number this 1, 2, 3, 4, 5, then we would know that on a carbon number 2, there's a methyl group. And here we go. This is the formula. The structure.